skills to empower futures live. In Kenya schools, we're on the rise. Our dream takes flight to new heights. Oh, we're climbing step by step, building future strong and safe. CBET, changing lives anew. In CBET, watch us break.
I take this opportunity to welcome our viewers back to this presentation. We proceed to give more insight on the trainees who are taking a CBET course, which is ICT Technician Level 5. The unit of competency is Develop Computer Program. And in our today's episode, we are going to look at one of the learning outcomes, identifying computer programming languages. And for that matter, in our presentation today, we are going to address the learning outcome, identify computer programming languages. Now, with me, I have the following. I start by types of programming languages. Programming languages are typically divided into categories based on their use and their level of abstraction. We have the first category, which we call low-level programming languages. And these are languages that are closer to machine code, which is directly executed by the computer central processing unit. Then we have assembly language, a low-level language that is specific to a computer architecture. It uses symbolic names for machine-level instructions. And then we have machine language, the lowest level programming language consisting of entirely of binary instructions, that is zeros and ones. Having gone through that category, we go to the second category, which we are calling high-level programming languages. And these are languages which are more abstract and closer to human languages, making them easier to read and write. And we have examples of such languages. We have Python, widely used for web development, data analysis, and AI and automation. We have C, a general-purpose programming language used in system programming and software development. And another example is Java, which is used for web and mobile development, especially for Android applications. We also have JavaScript, a scripting language commonly used for web development. Then we go to the third category, which we are classifying as object-oriented programming languages. These languages focus on organizing code into objects, which are instances of classes. And object-oriented programming promotes reusability and scalability of code. We have examples of these languages. We have Java, one of the most widely used object-oriented programming languages. Then the other example we have is C++, a language that extends C to support object-oriented programming. We also have Python, which supports both object-oriented and functional programming paradigms. Then we go to the next category, which we are referring to as functional programming languages. And these treat computation as the evaluation of mathematical functions and avoid changing state or mutable data. Examples of these, we have Haskell, a purely functional programming language, Lisp, known for its symbolic expression and powerful capabilities in AI programming. And we have the other category, which is scripting languages. And these languages are used for automating tasks and can be embedded into other applications or systems. They are often interpreted rather than compiled. Examples of these, we have JavaScript, which is used for adding interactivity to web pages, and PHP, a server-side scripting language used for web development. Having looked at these languages, then the next thing we focus on is factors to consider while choosing a programming language. Now that we have so many of them, which one do you use and for what purpose? And it is for that reason we would want to address some of these factors. Choosing the right programming language for a project is a critical decision that can significantly impact the development process, the quality of software, and long-term maintainability. And here are the key factors to consider when choosing a programming language. Factor number one is project requirement. The type of application to be developed, the nature of the project will often dictate which. Web application, system application, mobile application, machine learning. And of course, the other thing is performance. Such projects require high performance, such as games, real-time applications, or embedded systems. C, C++, and such are generally better in these cases due to their ability to provide direct control over hardware resources. The second factor to consider is the ease of learning and development. Some programming languages are easier to pick up, especially for beginners. Languages like Python and Ruby have a simpler, more readable syntax, making them good for those who are just starting. Then the factor number three is performance and efficiency. Execution speed is one of them. Some languages are faster than others. C, C++, and Rust are known for high performance because they allow for fine-grained memory control and low-level system interaction. Then memory management is another thing. Some languages like C and C++ give developers control over memory allocation and deallocation, which can optimize performance. Then the other issue is concurrency and multithreading. If the application requires handling many tasks at once, e.g. web servers, real-time processing, languages like Go and Java handle concurrency well with built-in support for Go routines and threads. Then factor number four is platform and ecosystem. Platform support. Some languages are platform specific. For example, Swift is mainly used for iOS and Mac OS development, while Java is cross-platform. Right ones run anywhere due to the Java virtual machine. Consider whether the programming language supports the target platform, for example, Windows, Linux, Mac OS, or mobile platforms. Factor number five is maintainability and scalability. Readability. Some languages are easier to read and maintain than others. Languages with a clean and consistent syntax, like Python and Ruby, promote easier maintenance. Then the code structure. Some languages encourage good software design principles. Java and C# promote object-oriented programming, while JavaScript supports both functional and object-oriented programming. Then there is the issue of long-term maintenance. Consider how easy it is to maintain and extend the code base. Strong typing in Java C# can help avoid errors, while dynamic typing in Python JavaScript may make rapid development easier, but can cause issues in large code base over time. Factor number six is development cost and resources. Availability of developers. The availability of skilled developers in the languages you choose. Some languages have a shortage of developers, making it harder to find talent. For example, C++ and Go developers might be harder to find than JavaScript and Python developers. Then the other issue is development tools. Ensure there are sufficient development tools such as the IDEs in integrated development environments, debuggers, and profilers available for the chosen language. Languages like Java and C# have rich IDE support in IntelliJ, IDEA, Visual Studio, which helps speed up development. Then the factor number 7 is security considerations. Security features. Some languages offer built-in security features to prevent common vulnerabilities. For example, Rust emphasizes memory safety, preventing issues like buffer overflows, which is a common security risk in languages like C and C++. Then we have ecosystem security. Some languages have mature ecosystems with security-focused libraries, while others may have a more experimental ecosystem. Then we have number 8, cost execution. Licensing and costs. Some languages and their frameworks require licensing fees or may be associated with specific vendor costs, e.g. Java's enterprise versions or C# for Microsoft products. For open source projects, languages like Python, Ruby, and JavaScript can be more cost effective. And then number 9, we have future prospects. Language popularity. The popularity and future demand for a language can influence the long-term suitability of your project. Remember, you don't have to keep on writing cons from time to time. Languages like Python, JavaScript, and Java are widely used, meaning there will be continued support and job opportunities. Finally, we look at integration with other systems. Interoperability. Check whether the language can easily integrate with other systems, databases, or external APIs. JavaScript via Node.js and Python offer great support for building applications that need to interact with various third-party services or databases. Then we have microservices. If you are building a microservice-based architecture, languages like Go or Java work well due to their focus on scalability, speed, and concurrent processing. In conclusion, we would say that when choosing a programming language, no single language is universally the best. The choice depends on factors like project requirements, performance needs, developer expertise, maintainability, community support, and platform compatibility. Here's a summary of some scenarios and languages you might choose. In case you have web development, JavaScript, Python could be the best options. System programming, we have C, C++, and Rust. Mobile development, we have Swift for iOS, Java, Kotlin for Android. Data science and AI, we have Python and R. Game development, we have C++ and Unity C#. Enterprise applications, we have Java and C#. Ultimately, the decision should be made on the specific needs of your project, the team's expertise, and the long-term goals of your software. I need to remind anybody who is pursuing the path of a program development that you should be ready to learn every other day, because programming is always growing, and at times it's growing faster than human beings. I wish you to stop there from Frokil's show, and we shall continue from there next time. Thank you for being our audience, and continue learning more from our channel. In our channel, we promised we share, we inform, and we educate. Politics aside.
Learning what's new with open minds, we engage and explore. Look a show, we inform, in wisdom we store. Through words we teach, and insights we proclaim. Together we grow, seeking knowledge flame. Lecture show, we share lessons in the air. Learning what's new with open minds.